Dear students, in this video I am going to explain dipole moment and valence bond theory VBT. What is dipole moment? The product of magnitude of charge on the poles and the distance between the two poles is called dipole moment. It is represented by mu. Mu is equal to Q into D. Q is equal to charge, D is equal to bond length. Here you can observe the diagram. In this diagram, there is a covalent bond between hydrogen and chlorine. But chlorine has high electronegativity. Due to that reason, chlorine attracts shared pair of electrons towards itself. So therefore, chlorine gets partially negative charge and hydrogen gets partially positive charge. So therefore we call this is the polar molecule. So one positive pole on one side, negative pole on other side. Charge into the distance between two atoms is called dipole moment. Here we can say the bond length. Bond length is D. So therefore charge into bond length is called dipole moment. Units for dipole moment is coulomb meter. Units for charge is coulombs and SI units for distance is meters or dBi units. dBi, DE, BYE. Let me explain the applications of dipole moment. Geometry of molecule can be determined. Percentage of ionic character of bond can be calculated. Here is the formula to find out the percentage of ionic character. Percentage of ionic character is equal to experimental dipole moment by calculated or theoretical dipole moment into 100. Cis and trans isomers can be separated. I will explain what is cis and trans isomerism in organic chemistry. The last and fourth application of dipole moment is bond angle can be determined. So after this, the regularly asked questions about dipole moment. Why H2O has dipole moment while carbon dioxide does not have? The answer is H2O is polar molecule with two polar bonds. H2O is bent structure with two lone pairs. So the net dipole moment is not zero, because the bond moments are not cancelled with each other. As far as the carbon dioxide is concerned, carbon dioxide is non-polar molecule with two polar bonds. Carbon dioxide has linear structure. So the net dipole moment is zero because the bond moments are cancelled with each other. Let us understand this answer with diagrams. Here you can see the oxygen has the two bonds with two hydrogen atoms. So this is the one bond, the covalent bond, another covalent bond. Because of electronegativity difference, oxygen has partially negative charge and hydrogen has partially positive charge. So dipole moment is a vector quantity. Hence it can be broken down into two vertical and horizontal components as shown in above. Here you can see that this is the dipole moment and this one also dipole moment. It is this symbol is represents dipole moment. But dipole moment is vector quantity. It can be divided into two components. One is horizontal component, this one is horizontal component, and this one is vertical component. You can see the horizontal components are in opposite direction. This is in this direction, right direction, it is the opposite direction. So pointing in opposite directions, hence will cancel out each other. The dipole moments will cancel each other. But the vertical components are pointing in the same direction. This gives rise to net dipole moment, leaving oxygen with permanent partial negative charge. So here the vertical components, this is the one of the vertical component and vertical component both in the same direction. So oxygen water molecule has some dipole moment. But as far as the carbon dioxide structure is concerned, carbon dioxide has a linear structure. This is the dipole moment is in this direction and it is in opposite direction. So here dipole moment 0.7 d between carbon and oxygen and also 0.70 for this bond also. So both in opposite direction. So it is a vector quantity. We can take in one direction is positive and another direction is negative. So net dipole moment mu CO2, that means mu means dipole moment for carbon dioxide is 0 because of this linear shape. Okay, let me explain the another important question on dipole moment. Why BeF2 molecule has 0 dipole moment although Be-F bonds are polar? Let me explain. BeF2 is non-polar molecule with polar bonds. It is also similar to the carbon dioxide. BeF2 has linear structure, so the net dipole moment is 0 because the bond moments are cancelled with each other. Look at the diagram. Here BeF2 at the central atom Be has 2 bonds with 2 fluorine atoms. So there is a dipole moment is in opposite direction and equal in magnitude. So if you add these 2 dipole moments, so the net dipole moment is 0. So therefore beryllium fluoride dipole moment is 0. So that is the end of dipole moment topic. Now we are going to understand what is valence bond theory. It was developed by Hitler and London. It is based on the overlapping and hybridization of atomic orbitals. A covalent bond is formed by the overlap of atomic orbitals. Next point, greater the extent of overlap, stronger is the bond formed. The extent of overlapping of orbitals is in order P' is greater than S' P is greater than S' overlap. So the last and final point, the direction of the bonds in the molecules is in the direction in which the atomic orbitals overlap during the formation of molecules. These 6 points are very important according to the valence bond theory. So valence bond theory mainly depends on overlapping of atomic orbitals. Let me explain with one example of this valence bond theory. Formation of H2 molecules according to VBT, valence bond theory. H2 molecule is formed by overlapping of 2 s orbitals of hydrogen atoms during the formation of H2 molecule. So we know that H2 hydrogen atom only one electron in s orbital. It is in spherical shape, and also the another hydrogen atom also has one s orbital is in spherical shape. When 2 hydrogens approach each other, there is a overlap, S' overlap. The 2 electrons are one pair of electrons are shared between 2 hydrogen atoms. So that is the end of my presentation. Thank you so much.